let's talk about histograms, pros and cons. Well, the pros are when you have a large number of values to plot, just like with things like friends, right? That's certainly a variable where you have a large number of values, but also things like number of tagged photos, right? That's going to be a large number of values, right? Some people have just a few photos. Some people have a ton of photos, right? So those kind of variables have a large number of values to plot. And in that case, a histogram is really nice, particularly a grouped histogram. Also, a histogram is good if you don't need to see individual values. And a histogram will definitely show you the general shape of the distribution. For example, in the case of friends, we see that it is a right-skewed distribution. One con, though, is that if you have many, many distributions that you want to compare simultaneously, histograms are going to be a little bit hard to do. You could probably compare up to 2 separate distributions on one histogram and see how the distributions look. But more than 2, it gets a little bit clunky. All right, now let's talk a little bit about frequency versus relative frequency. Frequency is simply how many cases have a particular value. So how many people have between 0 and 100 friends? Well, maybe it's something like, I don't know, I forgot how many it was, but maybe it's 250 people, right? How many cases have a particular value between, let's say, 101 and 200? Well, maybe that's 240 people, right? So this is basically what frequency looks like. It's just counting. Now, relative frequency is what proportion of cases from the sample have that particular value. So if you had 250 people having friends between 0 and 100, having between 0 and 100 friends, what is that in relation to your entire sample? Well, if your sample, if your N is 1,000 people in your sample, then it would be 25% or 0.25, right? And then between 101 and 200, instead of being 240 people, it would be 24% or 0.24, right? So pretty simple idea, but it'll come up again in the future. All right, now let's go into some problems. All right, first example. If we wanted to visualize the distribution of uploaded photos, should we use dot plots or histograms? Why, right? Well, let's think about uploaded photos. Is it like months where there's sort of this set finite number? Or is it more like friends, the variable friends, where there's like just a ton of potential values? Well, uploaded photos, I'm pretty sure that people have up to like thousands of uploaded photos sometimes. So I'm thinking that it looks more like the distribution of friends than it looks like than like months, right? And uploaded photos, because there's so many values, we probably want to use grouped histograms as well. We probably don't want to look at every single value. How many people have 1 photo? How many people have 2 photos? How many people have 3 photos? All the way up to like thousands. Instead, we'd probably want to look at them in a grouped way. How many people have between 0 and 500 photos? How many people have between 501 and 1,000 photos? And why? Mostly because there are going to be a lot of potential values. Right? And values is what we always plot on our x-axis. And whenever you could sort of imagine these values being like cut up into like thousands of pieces, you probably want to use grouped histograms. All right, example number 2. Consider this dot plot with the age of pennies in a sample collected by a statistics class. What are the cases and the variables that you see here? All right, so it's really asking you, what does each little dot in my dot plot represent? Well, I know that each dot probably represents a penny, right? But not just a penny. It has to be some sort of number about the penny. And so I can see, oh, it's actually the case is the penny, and the variable that it has is the age, probably in years, because that's what's written on the penny, right? It says like, oh, this penny was made in 2010, right? All right, so what is the shape of this distribution? Well, this looks to me, if I just draw a little outline here, I sort of draw this outline, this looks to me like a tail. So I'm guessing this is a right skewed distribution. And why does it have this distribution? Okay, that's going to take a little bit of thought. Well, it looks to me as though lots of pennies that are in circulation are pretty new, and then there aren't as many old ones. So maybe it's because there's this wall right here. Penny can't be any newer than 0 years old, right? So you can't quite go past that. And probably a lot of pennies that are really old sort of fall out of circulation, or maybe the U.S. Mint sort of takes them out of circulation, right? So that's what I would answer. All right, let's go on to example 3. Consider this histogram of mammal speeds. Is this a grouped or ungrouped frequency distribution? Well, to me, it looks like there are bins here. This is probably a bin that goes from 0 to 10, and this is between 10 and 20, and this is between 20 and 30. So in here, there might be animals that are able to run at 23 miles per hour or 28 miles per hour, right? So I would say that this is a grouped frequency distribution. This is a good question. If we used relative frequency, would this change the shape of our distribution? Well, let's reason about that a little bit. Well, these peaks right here, these animals are running at speeds of between 30 to 50 miles per hour, and that seems to be the mode, the most frequent type of mammal, right? And that's probably not going to change if you take 6 and divide it by however many animals are here, right? This should still be the peak, and this should still be the peak. This should still be one of the lower values. This should still be one of the lower values. So I'm going to say that this would not change. No, it would not change the shape of our distribution. Well, I've made the relative frequency distribution down here, right? And you could see that even when we put it in percentages, that the shape of it looks largely the same, right? So that's one handy thing to find out, that when you use relative frequency, the distribution doesn't change. We're going to be using that in the future. Last example. In this histogram of life expectancy, which do you think is bigger, the mean, or remember, it's like the balancing point of this distribution, or the mode, the most frequent value? Explain. All right, so in this histogram of life expectancy, the mode is probably the easiest thing to figure out at first. We could see right here, the biggest peak is at around 70-ish in life expectancy. So each of these little bins look like they're 4 years. So this is probably between 68 and 72 years, right? So that's the mode. But where do you think the mean might be? You have to sort of imagine taking this whole thing, cutting it out with cardboard, and trying to balance it on your finger. I actually think that you'd probably have to balance it somewhere here, right? Like not too far down, not quite in the middle, but somewhere like here, right? That's what I'm going to guess. And that might be the mean, whereas this is the mode, right? Because if I put my balance right here, I think it'd probably tip on this side. So I'd probably shift it over a little bit. And so this looks like my mode is my bigger value than my mean, right? And so explain. I don't know if I've already explained. I think I've already explained it, right? In my thinking. My mode is right here, but my mean is a little bit over here because I think that if I balanced it right underneath the mode, it would tip on that side. There would be too many people over here on this side. So I'm going to move over my mean, and because of that, I can clearly see that my mode is bigger. So there you go.